Okay, so here we've got a question that talks about an incomplete table and histogram, gives some information about distances walked. So we're dealing with a histogram and therefore dealing with frequency density. So the first thing we have to kind of recognise is formulas for working with histograms. So frequency density is found by doing the frequency of the interval divided by the width of the interval, so the width of the class interval. And a rearrangement of that tells me that the area of a bar, when the graph has been drawn with frequency density down the y scale, then the area of the bar equals the frequency. Because basically the area of the bar is the width of the class interval times the frequency density. So therefore the area equals the frequency. So we can use those two facts then to start thinking about how we do this question. But at the moment we've got no scale up here, so there must be some information to get that. And if we look at here, then we always add on to this table the column frequency density and calculate any values we can. Well, for this table we can see that we've got 210 as the frequency, divide by the interval width, so that's going to be 300. So 210 divided by 300 is going to be 0.7. 21 divided by 3 is 7, and we're dealing with a fraction that is smaller than 1, so 0.7 makes sense. And here we've got another interval, so we've got 350 as the frequency, divided by 100, and 350 divided by 100, 3.5. So we must have one of these bars to help us do this. Well, when we look at the histogram that's already started to be drawn, then we can see here this was 300. So 300 to 400 has to go to a height of 3.5. So we can see if we use this scale carefully, then it's going 1, 2, 3, 4. And we check, is that 3.5? Yes, it is. So that allows us now to see what our scale is. And because of that we can now fill in these, because we recognise the frequency is the area of the bar. So the 400 to 500 is here, and that has a height of 3.5, 3.6, 3.7, 3.8, 3.9. So to get this answer here, we know that something divided by 100 equals 3.9. Well, we come backwards by timesing. So 3.9 times 100 is 390, so this will be 390. And for the last bar, we can see that it's got a width of 500. So here we're dividing by 500, and that gave us a height of 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So that gave us an answer of 0.8. So again, we come backwards to get our frequency by timesing. So 0.8 times 500, well, 8 5s are 40, and therefore it's going to be 400. So those are our two frequencies filled in. It then says use the table to complete the histogram. Well, there is only one bar missing, and that's between 0 and 300, and we saw from here that 0 to 300 had a frequency density of 0.7. So using the scale, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So we know that this bar is going to be this high. You should be using a ruler. We can see that this is the way that it's going to work. So that's the bar that's missing. So the important things about histograms is remember the formula, frequency density equals the frequency divided by the width of the interval, and it's for histograms really for unequal bars, unequal unequal class intervals, and they're to even out the spread of the frequencies so that we're using this frequency density, so it's 0.7 per kilometre and so forth. Quick recap of histograms.